Hello everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge 540 single element in a sorted array. It's an easy problem to solve. So we'll be given a sorted array, and every element in that will appear twice, except for one. And you have to find out that particular element which is present in the array only a single time. Okay. And they have given this restriction where we have to write the solution so that it takes order of log n time to execute and order of one space. So basically, you will not use any additional space to solve the issue, and you basically somehow have to just uh, divide the complexity by two in each step. Okay, so as soon as you see something like this, where you have to take a log of n time to solve, first thing which should come to your head is to use a binary search approach or something related to binary side. Okay, because in binary solutions, you basically just divide your problem into half at each individual step. So that's what exactly we're gonna do over here. So what we will be doing is, for example, we'll have two pointers, left and right pointer. Left pointer will be initialized to the leftmost element or the leftmost index of your subarray, and right will be at the last element of your subarray. So once you have left and right, you will figure out a middle element. Okay, for example, let's say this is the middle element at the moment. Okay, now if you check if the element on the right or the element on the left is same or not. If any of this is same, we can definitely say that this is not the element which we are looking at. Okay, because it appeared at least twice, right? Then you have to break that part, like break the problem into the half, like in which half you'll have to pick. For example, if this is not the element, we'll have to either pick left or the right, right? So how you'll be doing this is, uh, if you notice this, every time, every time like you observe an array, there will be 2n plus one element, right? It will always be a uh, it will always be an odd sized array because for every for most of the elements or except one element, every element will occur twice and there will be one element which appears single time. So now what you have to do is check if the element on your left is equals to your mid element. Okay, if yes, then you will consider this whole array, and you basically have to check if the length of this subarray is divided by, if it is divided by 2, you will pick the other array. If not, so basically essentially you'll have to pick the odd sized subpart. Okay, so this is it. Let's check out the solution. Okay, let me just zoom in a bit. Yeah, so for the solution, you need a few variables to be defined first, right? So as we talk, we need a variable which will basically point to the leftmost element of your subarray. Similarly, you need a right, and we are initializing it with 0 and length of nums minus 1. Okay, so in basic binary approach, what do you do? Like we check for while left is smaller than or equal to right. Okay, we want to run this loop again and again. Okay, next thing is we have to find out the middle element. So mid is equals to left plus right and floor division 2. I should include this in. Okay, so we'll get the middle index of our subarray. Now, there is few conditions which you need to check. Let's say if your mid is pointing to uh, the zeroth index, right? Then of course, like if the element on the right is not equal to my current element, then I can say it is that is the element which we are looking at. So to do that, what I'm doing is if mid minus 1 is less than 0 or nums of mid minus 1 not equals to nums of mid. So basically, we are looking for all the left element with this condition. Either this condition gets satisfied or this condition. Okay. And we need another condition to check for the right subparts. And I'll be looking for if my mid plus 1 is equals to length of nums, then it doesn't make any sense to check on the left part, like similar to what we did over here. Or my nums of mid is not equal to nums of mid plus 1. Okay, so this is the condition which we'll be looking at. If any of this condition gets satisfied, I want to return the element at the mid. Okay, once like if we were not able to satisfy this condition with the current mid element, we had to check the size of the array, right? To pick the next sub array. So to do that, let's take a variable in which we'll be storing this. And what I want to do is I want to check if my nums of mid minus 1 is equals to nums of mid. In this case, I want my left size to be mid minus 1. Okay. Otherwise, I want it to be n. Okay. Now it's simple. We always wanted to pick the subarray with the odd number of elements. So if left size percentile 2, if percentile 2 basically is divisible by 2, then right will be, we will basically update the value of the right pointer. Else, I want to update the midpoint. This is basic, binary search condition. And this is it. Like this was the whole program which we need. Let's check out the test cases. Okay. Int object is not subscribable. Oh, sorry, I should have used length. M is not defined. Where is it? Okay, this is made. Sorry about the typo. Okay, so the test cases were clear. Let's submit for further evaluation now. The solution was accepted, and we performed decent. Like we have performed 59.3% of the submitted solutions. So yeah, thanks so much for watching out the video and stay tuned with the upcoming ones. Don't forget to subscribe to the channel. Thank you.